This insect looks like something you might find in a sketchbook, so finely detailed that you can make out its body segments and tiny, spindly legs. It almost looks like it could crawl off the rock, but these fossils are actually between 33.9 and 55.8 million years old. Insects are notoriously rare to fossilize. The vast majority of all fossils are marine in origin, and past that they are made of the hard, sturdy parts of animals, not delicate exoskeletons and wing membranes. These were preserved by a method called carbonization. Carbonization happens under very specific circumstances. First, the creature must be protected from the decay very quickly after it dies. After that crucial moment, the organic molecules of the insects, made of oxygen, hydrogen, and carbon, are put under pressure and heat such that the oxygen and hydrogen are pressed out and only the carbon remains. So what you're seeing right now is actually the very carbon that the insect was made of, a part of its actual body. Here is a spider. If you look carefully, you can see its chelicerae, or mouth parts. And here you can see a butterfly, some of its patterns still visible. Something so perfectly plucked out of an ancient sky isn't only amazing for its own sake, but also because of all we can learn from it. All of these are from the Green River Formation, a fossil locale known for its incredible preservation of not only insects but many other Eocene creatures, and most famously its fish. As you look at these fossils, you'll notice that not only are hard parts like bones preserved, but also soft parts of the body, like fins and skin. This is another incredible advantage of carbonization. The only other ways that we can see ancient soft tissues like this are in creatures preserved in ice or amber. Researchers also value these fossils so much because they are incredible windows into the evolution of animals that we normally would not have fossil evidence of, as well as for the incredibly detailed morphology that the method of carbonization preserves. The fossil you're looking at now is a frog, and this one is a bat. The Green River Formation also includes many plant fossils, and these, in conjunction with the fossils of crocodilians and boas, help scientists to conclude that this was a warm, temperate subtropical environment, which is different from the climate of Utah and Wyoming, where we find the formation today. The sedimentary rock around a fossil, or the sedimentary context, is just as important as the fossil itself when we try to understand an ancient environment. A general rule of thumb in geology is that sediment only accumulates when it is protected, usually by a body of water, otherwise it is eroding. One important aspect of the environment that we can understand from the ancient sediment is the type of environment a sediment was deposited in. Based on the grain size or the size of the particles in the rock, we can say whether this was a marine, river, lake, or even glacial deposit. From the sediment of the Green River deposit, very fine-grained siltstone, mudstone, and limestone, we know it was deposited by a system of Eocene lakes. This system consisted of 3 different lakes: Fossil Lake, Lake Goshoot, and Lake Uinta. This is a map of those lake systems through time. These maps were carefully put together by studying the sediment layers in the formation. Notice that Lake Uinta lasted for 17 million years. Most of the fossils we find in the formation come from Fossil Lake. It was both the smallest and the deepest of the lakes, and existed in the early Eocene. Fossil Lake's main features are a calcite limestone bordered by oil shale. Many fish are found in the limestone, and plants, insects, and mollusks are found in the oil shale. Lake Goshoot existed during the Middle Eocene and was a playa lake. A playa lake is one that dries up during the warmer months of the year and fills in the colder ones. We know Lake Goshoot was a playa lake because there are layers of rock with mud cracks, a sure sign that the lake dried up periodically. Lake Goshoot also contains many fossil fish, although it is more likely to produce casts and impressions than the more famous carbonizations. The final lake, Lake Uinta, was shallow and lagoonal. It does have many fossils, but they are much less studied because of the substantial amount of oil also contained in this unit. I'll close this out with a final thought about the importance of these fossils. Knowing about the past is not only a wonderful thing for its own sake, but it helps us connect our present to the context of our geological past. Natural selection and evolution is almost impossible to study on human timescales, so we must look to the past in order to understand our future. There is an incredible beauty in the fact that these tiny, fragile, insignificant insects survived in perfect detail for millions of years. It's so wonderful that it feels like magic, and that feeling only compounds when you appreciate just how much they can tell us about the past and their lives. I think that as tiny, insignificant humans in an impossibly large universe, we can take some comfort in them.